So it says graph the function f of x is equal to 3 cosine 2x plus 1. I know it's got 2 cosines for some reason. Whenever you put something in an equation creator, it'll duplicate it in Google Docs. So I'm not sure why that works. But anyway, just forget about one of the cosines. That doesn't mean anything. If you see sine or tangent or anything like that, just ignore one of them. Now, first thing you do whenever we graph, we're going to list our amplitude, our period, our horizontal translation, our vertical translation, and the midline. So what is the amplitude here? 3. What is the period here? Why is it pi? Where did you get that from the function? Why is it over 2? The 2x, yeah. So we always have 2 pi over 2, and that is just simply pi. What about h? What's our horizontal translation? Nothing, right? There's nothing there. It has to be inside the parentheses for it to be a horizontal translation. K, that one's easy. Up 1. So what does that make our midline? 1. So let's go ahead and just do a little dot here for our midline. Now we can graph it. This is a cosine function, correct? So where are we going to start at for our cosine? If we're going to start on the y-axis, we're going to start at the very top, right? Where will it be? Where will the very top be? At 4, yeah, because our amplitude is 3. So if we go up 3 from the midline, it's going to start at 4. So it's going to repeat every pi, correct? So we can go ahead and just place our dots across the 4, which means at pi over 2, it's going to be at the minimum, which would be -2. This is going to be look all a little cattywampus here, but that'll be all right. So we're just going to act like that went through the dot perfectly. It's going to look something like that. Everybody got that? Period repeats every 2, or it repeats every pi. There we go. And B just simply says graph the midline, which you should graph the midline anyway. So there's that answer done. Now explain how you can find the midline, period, and amplitude in part B from the function. Well, do we really need to go over that? Midline is what? Here's the midline. What else did it want? Amplitude. And period is 2 pi over 2. There's the period. Everybody good with that? Everybody understand where we pulled all those from? All right. D says, construct a periodic function that has a period of 8 pi, a midline given by the equation y equals 5, and an amplitude of 1/2. If you want to, I would go ahead and just write it out. Amplitude is equal to 1/2. Period is 8 pi. So if it's going to be 8 pi, what does that mean? We're going to write. Well, let's just do this. 2 pi over 8, right? That's going to be our period. Doesn't talk about a horizontal translation, so we're not going to worry about it. Midline tells us that it's going to jump up 5. So if we rewrite that, does it tell us which type of function? No. All right, do we want to write this as a sine or a cosine? All right, let's do sine. So f of x is going to equal what? What's our amplitude? 1/2 sine. Because Amy said sine. I mean, it doesn't matter. Because we can always write it in sine or cosine. We can write it either way. Does not matter. I'm going to rewrite it over here so I might have a little bit more room though. Okay. F of x is going to be equal to, amplitude was 1/2, so 1/2 sine, then what? What's going to be our period? Pi? 4 pi?
Oh, 8 pi? 8.
I wrote it right here.
Isn't it 8 though? Because 2 pi is from. What did it be? So is PW? Or is it different?
What?
So is PW or the P?
Is PW or what?
Omega. So isn't it just 8 though? Not 2 pi?
No, because you're going to have to, if you're going to say that the period is 8 pi, you're going to have to tell me where that is in terms of a full rotation. So that's the reason why we're going to put it on the bottom, right? It's telling you that it's going.
What about the pi in 8 though? That's true.
What are you saying? Because it has a pi there? What if it had said 8 days? If it repeats every 8 days. Do we care? Because we're wanting to put it in terms of a full rotation, which is 2 pi. That don't matter. We're still going to put it on the bottom. If it says that the period is 8 days, we're still going to say 2 pi over 8.
So we just write 2 pi over 8x? I thought it was just 8x. There's a 1.
No, it should be 1/4 x. 2 over 8 is 1/4. And then there's no.
You just got rid of the pi there.
Oh, yeah, sorry. Well, yeah, we don't have to have pi there. We don't ever have pi there. Look in number 1. You didn't have pi up there. You said 2x. You don't need pi. You know that that's what it is. You would convert that back and say that that's going to be 2 pi over 8. You can convert it either way. And then just plus 5 to raise our midline. That is a horrible 5. Okay? Everybody good with that? All right, let's go to page 2. The graph below shows the number of daylight hours each day of the year in Fairbanks, Alaska, as a function of day number, as a function of the day number of year. Okay, that's weird. January 1 is day 1, January 2 is day 2, and so on. Okay, So find a function that models the shape of the daylight hour curve reasonably well. Once again, are these going to be absolutely perfect? No, but we're going to do something reasonably well and define your variables that you use. Okay. How are we going to find the amplitude? That's the first thing. Let's start with amplitude. Amplitude equals omega equals h equals k equals y equals. How are we going to find the amplitude here? How are you finding that?
The maximum minus minimum divided by 2.
Say it again.
F maximum minus F minimum.
F maximum divided by the minimum. Or minus the minimum divided by 2. So if you said 21 minus 4 is 17 divided by 2. Is that what you're saying?
No.
That's maximum minus the minimum divided by 2.
So is it wrong?
No, that's what I'm asking you. Is that correct? Yeah. So the easiest thing to do probably, I mean, that's exactly how you find it, but I need to kind of see it as well. So what I would do, I would go ahead and graph my midpoint. Okay? So what's the midpoint going to be? Somewhere right in there, right? It's going to be close. So now then, the amplitude, just like she said, if we said 21 minus 7, no, not 7, minus 4 divided by 2 is equal to, so we want 8.5. I would probably leave it in the fraction form because we're used to dealing with fractions in our period and everything. I'd probably just leave it in the fraction form. Okay? So yeah, that's our amplitude. And check yourself. If we say that the amplitude or the midline's about 12.5, if I add 8.5, I get 21. So there we go. That's the amplitude. It's going to go up, and then it's got to go down that much. All right, so what is going to be our period here? This goes back to it. What we were just talking about. What's our period here? When is it repeating? $350? Think about the context of the problem. What are we looking at? An entire year, right? So let's call it 2 pi over 365. 365 days. That makes sense? It's basically repeating every year. Daylight savings or daylight time, if it was 4 hours on January 2nd, and it's 4 hours again on December 28th, let's just make it easy and call it 365. Every year, it's basically a complete rotation. Okay, see why we don't have to have a certain number down there? Or to put pi or whatever. We just know that's the rotation. All right, what is our horizontal translation now? Where are we going to start this at? We're starting on the y-axis, right? What kind of function is this going to be? Why? Why is it a negative cosine? Remember, if it repeats and it looks like an S or a Z, that's our sine function, right? When it repeats then. But here we're going to say it's going to repeat on almost like a parabola, which that tells us it's cosine, but we're starting at the bottom. So we need to flip it. So this is going to be a negative cosine. So therefore, there's not going to be any type of horizontal translation. Our K and our midline are going to be the same thing, right? About 12 and a half. Let's just call it, yeah, we'll just do 12 and a half. I don't want to mess with improper fraction. Okay? So there it is. So now let's write it. F of x is equal, what's our amplitude? 17 over 2. Negative 17 over 2. Cosine, what's our period? We'll just leave that as 2 pi over 365. Plus nothing. And we called it x, so we'll leave it as x. And then plus, what's our 12 and a half?
I still don't get the omega and period. So is a period 2 pi over omega? So
Omega is,
if we would graph, formula, should it be?
omega is equal to 2 pi over your period. However one rotation is. Or not one rotation, but whenever it repeats. Omega is equal to 2 pi over whatever the repeat is. Here the repeat is 365 days. So we're converting that into radians basically. We're saying if this one repeats at 365 days, then we want to convert it into a complete rotation of the sine or cosine function. When does a sine or cosine function repeat? Sine every 2 pi, right? So that's the reason why we put 2 pi over whatever it is. If it had been 7 hours, we would put 7 on the bottom. Because we're converting it into a 2 pi rotation. Okay? What does cosine look like normally? A regular cosine would have been something like this. Right? Where it starts at the top. Remember I said cosine, if it's starting at the y-axis, it's going to start at the top. Sine's going to pass through the 0. Right? But here we're not starting at the top, we're starting at the bottom. Which means it's flipped. The cosine is flipped. B, explain how you chose the number in your functions in part A. What is the main line? Okay, so we did all of that for part B as well. Everybody good with that? Everybody see how we did that for B? Or for the original? All right, C. On page 3.
A and B, we already did it there.
Yeah, all that was done there. It was just explaining how we come up with those numbers. A friend looked at a graph and wondered what was the average number of daylight hours in Fairbanks over the past year. What might be a reasonable answer to that question? Use the structure of the function that you created in part A to explain your answer. Okay, so if we're looking at that graph again, let me get this off of here. What could you possibly say is the average hours?
Are you page 3?
Yep, C. You may have to go back and look at the graph though.
I only see D. Oh,
Come on, take a guess. What's the average hours? 12.5. Where did you get that? It's your midline, right? That'd be a good guess. There should be as many values below the midline as there is above the midline, right? So therefore, that would be your average hours.
Is it always the midwife or just for this function?
It'd always be.
I don't want to spit.
12 and a half hours. According to the graph, around which month of the year did the first day of the year? Which month of the year did the first day of the year with 17 and a half hours of daylight occur? Does your function in part A agree with your estimate? So we're looking for 17 and a half hours. What is the first month that that's going to take place? We would probably say maybe this one. Well, I think this would probably be like 17. Either way, somewhere between 100 and what? 20 days to 150 days. So what month do y'all want to take a guess at that at? So what day? May? Okay. How would we use our function to figure that out? Plug in what? Two X. You said plug it in to X, not plug in to X?
Plug it to X.
Yes, okay. I thought you were saying plug in 2X. I was like, where is she coming up with 2X from? Yes, we want to plug in, but what are we going to plug in for X?
17.
We're going to plug in what day we think that is. X is our x-axis value. So let's just call it what? You said 155. I said somewhere between 120 and 150. Let's call it 140. Okay? Maybe split the difference. Let's call it 140 and see what happens. So if we had negative 17 over 2 cosine, was it 2 pi over 365 times 140? Why did I put a decimal there? 140 plus 12 and a half? Okay. All right, if we plug that in, what do we get? A calculator, that's what we get. Right. So let's go with yeah. All right, what do we get? You don't know? Anybody want to work their calculator skills here and tell me? What did you do for pi? Did you plug in 180?
140. Oh, pi? No, I just did it as pi.
You just did it as pi?
But it's weird. It starts with negative 1.70 and then minus 17 over 2.
I got 18.8.
Oh, that's hard about two. That's what you
If you'll just plug in negative 17 divided by 2
Degree mode?
No, radian. That's what about for radian.
radians.
I have a weird negative number in front of me.
Because you have to plug in the fraction as a negative after. Otherwise,
I got this to equal 18.8. So what is the 18.8? What is that telling us?
Uh,
What? That's the hours for the 140th day of daylight hours. For the 140th day, because that's what we guessed, it would have been 18.8 hours of sunlight. That's what it's telling us. So he's a little high on our estimate of 140. It's probably closer to 125, probably. I can't do it.
why is it higher than our estimate? Why is our estimate higher?
Because we picked the wrong day. If you go back to my graph, if you go back to the graph there, I said it could be anywhere between probably 120 and 150, and we picked 140. So if we pick probably 125, so plug in 125 for your number. That's probably going to be closer to,
Well, should the answer be 17.5?
yes.
So do we actually do it until we find the...
No, it just said make an estimate. 125 plus 12.5. I got 17.1 for 125 days. So maybe it's around 130. We're not going to keep doing that though. Okay? So now the scientists who reported the data now informed us that their instruments were incorrectly calibrated. Each measurement of the daylight hour is 15 minutes too long. Adjust your function from part A to account for the change in the data. How does your function now appear? Explain why you changed the formula as you did. What is that going to cause? It's 15 minutes too long. So what's going to have to happen? If it's 15 minutes too long, what do we need to do? Guys, if I said we measured Joshua's height and it was 15 centimeters too long, what would he do to find his height? We would subtract 15, right? So what does that mean in 15 minutes? Where is our hours at on our graph?
Y.
It's Y. So if we need to shift Y, which way? Down. We got to shift it down 15 minutes.
So is it
Right.
saying that this is 15 minutes off with the graph?
Yeah, they put it they added 15 minutes to too much for every day. Okay, so now we got to take it off. So how's that going to change our graph? How do we change our graph vertically?
Change the... Cleveland? No. No.
Okay, yeah, our K, right? We've shifted it up 12 and a half. We got to bring it back down 15 minutes, right? So what is it going to be? What, 15? That's a quarter? Quarter of an hour? So it would be 12 and a fourth is our K. We would change that to 12 and a quarter. We had 12 and a half, but we got to shift it down 15 minutes. Therefore, we have 12 and a quarter. Okay?
So 15 minutes is 1/5, so we just minus.
It's 1/4. Right?
Oh, okay.
Okay? F, to make very long-term predictions, researchers would like a function that acknowledges that there are, on average, 365 and 1/4 days in a year. Why is there 1/4 days? Remember, we have to account for leap year, right? That comes every 4 years because 4 days, or 4 years, there's one extra day because of the 1/4. How should you adjust your function from part E so that it represents a function that models daylight hours with a period of 365 and 1/4 days? Excuse me. What are we going to change there then?
X-axis. Right.
Where did we put? So instead, think about this. We use 365. Where did we use 365 at? In the period, right? So we need to change it in the period again. We need to, instead of using 365, we would just do 2 pi over 365.25. Yep. So that is our omega. Oh my goodness, why are you not working? What's that?
So we just put it back to the next function? Like, just,
What?
will you write the formula again?
Yeah, just write the formula again. Say we would change the omega to this. Okay. G says, do these two adjustments to the function significantly change the prediction as to which day of the year first proposes 17 and a half hours of daylight? Would it change it? Just think about it. Probably not a whole lot. We're only talking about a quarter of a change in each direction. They're saying if you plugged in, so whatever you picked, whether it was 140, 125, whatever you picked for the first day of 17 and a half hours. Okay. If you now do that again, is that going to change a whole lot? You can plug it in and see. Yeah, if you change your K and your omega, is it going to change your answer a whole lot? Did you do it? Did you just do it? No. If I did it, it would be 17 over 2 cosine. Wrong. 2. It's not going to change it a whole lot, but I'll do it. Divided by 365.25.
But if I just type in negative 17 divided by 2, it's weird. It changes every time I do it.
Plus 12.25. Mine's, so I got 18.8 the first time. I got 18.7 or 18.6 this time. Didn't change it a whole lot. There wasn't that bad of calculations off. Especially when we're predicting. So not much.
I just forgot and it
Explain what?
E.
Oh, E. Thought you said giga. The scientists who reported these data now inform us that they're okay.
It's just
So they predict, or they put too many minutes on each day. Okay, the hours we shifted up and down, right? So now that we're going to have to take off 15 minutes of each day, we would subtract it from our K, because that's how we've shifted up and down. So if you subtract it from your K, that's going to take into account that they had moved it up too high.
It's just 12 half minus 1/4 because 1/4 is 15.
Yeah.
Wait, so F, you didn't write the whole formula, but we have to write it, right?
Yeah, you just plug in what we changed. Yeah.
And can you, I don't know how to put that in the calculator. Mine has a weird calculator.
Josh, did you get it?